Hi, hello everyone. Welcome to my new video in vision architecture. So in this video, I gonna show how to train image classification model using resnet, and we have a custom model images. So let's go into the topic. So here is our custom model where I have took from Kaggle surface crack detection, where we have surface with no cracks, and I'll just show you in folder. So just wait a minute. Yeah, here it is. Uh, yeah, here it is. So inside this dataset, I have downloaded and I have splitted this dataset into train and test. So let's go into the train where we have crack and non-crack. So if you go into the crack, you could see the cracked images here. So you could see this. So here are many cracked, the surface crack defects. So using this images, we're gonna train it using ResNet. So this is non-crack images. We have these images in JPG format. So we gotta go here. And let's yeah. Here is my test set and train set. I have divided into 8, 90, 10. So here, let's go. Let's go into the coding. So yeah. So only this class I have created. All others are last video series. So let's go. First, I have imported my packages, that is torch vision and glob for going inside the folder. Then torch and that is neural networks. Then torch vision. I've imported my optimizers too. So let's first we have called the ResNet class. So I've took it from the pytorch documentation. So here we first call the convolutional network by using n sequential. Then we have conv2 layer. Then the layer overall is here. First we have called the residual class here. Then it is just a residual block, and we have ResNet here. Yeah, here we go. Here is the entire architecture of ResNet with 64 kernel size. Sorry, kernel size is 3, then 64. The compressed image is 64, then 128, then 256. Finally, we have 512 blocks. So with stride of 2 and padding with 1. So here is our architecture. So here is the lineup, the sequence of our architecture. First we have convolutional layer, then max pool layer, then we have normal layer, then another convolutional layer, then layer 2, layer 3, and we have average pool. With the finally we have the fully connected layer, that is dense layer. So we have given this, and we have created a class where before I've already created this class for you. Then I've just initialized my constructor with training path and test path, then with learning rate, number of epochs, number of transformers. So in transformers, we will resize the images into 224 into 224. Then by using random horizontal flip, we do data augmentations. Then we transform these values into tensors. Then we normalize to these values within 0 to 1 to, sorry, 0 to 1. So self-start device is CUDA. As we run in CUDA, my GPU is 1650. So yeah, let's then we have to load our train loader and test loader, and then we have to call the model where we have called here. So we have to call these model here, we have called it, and finally we add the optimizers in this model. So we have loss functions too, that is neural networks dot cross entropy loss, and we could give the number of epochs here. So let's give self dot number of epochs. So I've already given here. Yeah, we have here. So yeah, and we will count. We will iterate through the epochs. For each epochs, we have to train the model, like self model dot train. We have the training accuracy. So we gotta go here and we enumerate through the train loader. Then we will assign the optimizers. Finally, we get the outputs. Then loss. Here we calculate the training loss, and we finally make a prediction with validation set. And we will different like the difference between the prediction and the training loss is the actual, that is the predicted value minus actual value is our accuracy. So we have calculating the training accuracy. Finally we get the training accuracy equal to training accuracy and training count. So this is for the training set, and we do the same for the test set also. So test sets iteration is here, and finally I have created a method for saving this model. So I've saved .pt model here. Then I've created a method for saving the onnx dataset, like onnx for like I've created a method for saving our pt file into onnx model. So I have given the name, output name, and input name data, input name as data and output name as resnet 2410 forward. And after that we gonna call. So my dataset path is here, and I just want to call this model obj equal to give model train path test path learning rate and number of epochs. So finally I gonna call my save onnx method, and I've already trained it, guys. If you want to check it out, you could try my code, and the code link is in description. Please check out and please do train. I've got this training result. So first I've got the training accuracy as 90, that is 90 percentage. Then the test accuracy is 93 percentage. So let's go on. I've increased my test training accuracy to 95 percentage and test accuracy to 80 percentage. This is a little bit fluctuated, but believe me, if you train with 30 or 40 epochs, it's gonna work out. You're gonna get the results with you're gonna get the results with amazing theory. So believe me, guys, your strategy, I mean your stat will go up when you increase your image size and reduce your batch size. Then if you're gonna train with number of epochs, you're gonna get higher accuracies. So but don't get above the limit. Please do train your model with limited epochs. So that's it, guys. Stay tuned with for next video, and thank you. Bye bye.